information. Today we are going to build our first model using logistic regression. So what is logistic regression? It is used to predict the probability of an outcome. The outcome can be binary, such as yes, no, or will this customer buy my product, or multiple outcomes such as what will be the quality of wine, will it be low grade, high, or average, or will this email be primary, promotional, or social email. The point to note is it's a supervised learning method and we must provide a data set that already contains the outcomes to train the model. Alright, so what does that mean? Before we start building the model, let's first try to understand how the equation for logistic regression has been derived. As you know, a simple regression may have an equation such as y equal to b0 plus b1x. In our previous example of number of claims versus age of the insured, we get an equation such as number of claims equals to 18 plus b1 times the age, which gives us a line that passes through the points. And if we get a new data point with age value, we can predict the number of claims using this regression line. The line can take any shape and form depending upon the equation. But what if the data is not as we expected and the question we are trying to answer has only two possible outcomes, such as what is the probability that this customer will buy my product? If we draw a line like this for the data points, it will not give us the correct result. Alright, so let's take a step back and ask ourselves, what is the question that we are trying to answer here? Well, the question is, what is the probability? As we all know, probability is always positive and is always less than or equal to 1. But our equation here is y equal to b0 plus b1x, and y here can take any value including a negative value, but probability should always be positive. So what do we do about it? Well, let's try to solve it and see where we land up. So what we do is we apply an exponential function on both the sides of the equation. This should take care of the first requirement, which is it should be positive, as exponent of this equation will never be negative. Alright, the second set of condition for probability is it has to be between 0 and 1. And how do we do that? Well, it's very simple. To make it less than 1, we simply divide this further by a number that is greater than this particular value. So we simply add 1 to the exponent of y and divide the whole equation by the same. That gives us the probability of success. And if this is the probability of success, then probability of failure would be 1 minus p, because the overall probability is always 1. And hence our equation now looks like this. If we solve this further, our probability of failure will be 1 upon exponent of y plus 1. Okay, and I ask you to solve it further, which will basically give you p upon 1 minus p as equal to exponent of y. Next, we perform the log function on both the sides, which will cancel the exponent, and what we get here as y is nothing but log of p upon 1 minus p. which is nothing but B0 plus B1x. And now when we plot this on the graph, it looks like this, which represents our data much more accurately than a simple linear straight line. Now we can predict that the data points which are above a particular threshold, let's say 0.5, will be positive and others as negative. The threshold value can be decided based on the business application and what is the cost of finding false positives or false negatives. What I mean by that? Well, if you are trying to find out whether a particular transaction is a fraud or not, you may want to set this threshold little low. That may lead to some false positives. However, it is okay to get some false alarms rather than allowing a fraudulent transactions to pass through where the cost will be much higher. I hope that clears the concepts behind logistic regression. In the next lecture, let's build our first model using logistic regression in Azure ML. So log into the Azure ML Studio as I want you to do this along with me. Thank you so much for joining me in this one, and I'll see you in the next lecture. Until then, enjoy your time.
Ok.
Nói chung là outcome đó là probabilities và dựa trên công thức log. Nó là supervised learning và đáp án kiểu categorical là classification.
Nó hỏi là which of the following is not used when analyzed? Accuracy. Trời, cái này không biết. Tôi chọn đại thì Tú ơi, Tú biết câu trả lời của thầy.
Cái này là để đánh giá model. Tôi nốt lại này để học thêm. Cái đáp án cuối cùng là gì ta?
Accuracy chắc không phải đâu. Em nhớ có A square với Rocker phải thôi. Thử đại nha.
Hello and welcome. So far, we have covered a great deal of course. We have covered data transformation as well as theory behind logistic regression and the parameters associated with. We even created our own model for loan application outcome prediction. In this lecture, we are going to cover how to interpret the results of evaluate model. So let's go to our model in Azure ML Studio. So here is our model that we created. We first imported the loan prediction dataset, cleaned some missing values, selected the columns that we wanted in our model prediction, split the data for training and testing, applied two-class logistic regression and trained it, scored it, and finally ran an evaluate model. Let's now visualize the evaluate model. Our output appears something like this. So what does that mean and how do we interpret these results? So let's go back and look at the output of score model and visualize it. Let's go all the way to the right, and as you can see in our test dataset, there are actual positives and negative values. We can assume y as a positive value and n as the negative value. And then after we ran the score model, we had predicted results which also were positive and negative. And in some cases, the actual and predicted results are different. All right, let's go and see what all these things mean in the form of evaluation of the result. Let's try to plot the positives and negatives in the actual versus predicted metrics. So we have actual positives and negatives as well as predicted positives and negatives.
Vậy nó là
All those positive cases where the actual results and predicted results match, we call them as true positives. So they are true and they are positives. Those results where predicted and actual both were negative, we call them as true negative. So they were truly negative in the form of actual and predicted. And results where we predicted it as positive, but in reality it was a negative result. Meaning we predicted it as y, but it was actually an n. These were all the false positives. Similarly, we may have some results where they were actually positive, but we predicted them as negatives, and these are false negatives. So let's try to understand this confusion matrix and other characteristics using an example. In this graph, let's say all the circles are positive results and all the triangles are negative results. And our model predicted these results as positives and these ones as negatives. In that case, our true positives are all the circles within the blue line, which is 8 in number, and our false positive will be this one triangle that was actually a negative, but we predicted it as positive. Similarly, we can also calculate the false negatives and true negatives. We also sum it up across predicted and actual results. All right, I'm sure how the confusion matrix is constructed is now clear. Let's now learn how the characteristics of accuracy, precision, recall, and F1 score are computed from the confusion matrix. Well, accuracy is nothing but the proportions of total number of correct results. So the correct results are all true results. So in simple terms, it is true positive plus true negative divided by the total number of results or total number of observations. So in this case, we have 8 true positives and 4 true negatives. So the total number of observations are 15. So accuracy here will be 8 plus 4 divided by 15, that is 0.8 or 80%. Similarly, precision is the proportion of correct positive results out of all the predicted positive results. So that is nothing but true positives divided by all the predicted positives. How many correctly identified as positives? That is true positive. Hence, we divide that by the total number of predicted positives. So here we predicted 8 true positives and total predicted positive results are 9. So it is 8 divided by 9 and hence the precision is 0.889 or 88.9%. Next result is of recall. Recall is the proportion of actual positive cases that the model has predicted correctly. Okay, so it is nothing but the true positives divided by the total actual positives. So in this case, we have total 10 results as positive, but we could only predict 8 correct and 2 as false. Hence, in this case, the recall is 8 divided by 10, that is 0.8 or 80%. All right. That is some mathematics and some amount of ratios that we have seen. The last one in this list is the F1 score, which may require some explanation. Well, F1 score is the weighted average or harmonic mean of precision and recall. When measuring how well you are doing, it's often useful to have a single number to describe your performance. We could define that number to be the mean of precision and recall. This is exactly what the F1 score is. The formula is as given here, and value in this case will be 0.84. The only reason why we use the harmonic mean is because we are taking the average of ratios or percentages, and in that case the harmonic mean is more appropriate than the arithmetic mean. Let me explain that by an example. In case you already know, you can skip it or stay with me for a revision of the concept. Let's say our model has identified these 6 positive results. Hence, our confusion matrix would look like this. Applying the formulas, our precision is 100% because we only identified true positives. We didn't identify a single false positive, and the recall is only 60%. Now, if we want to compare it with the previous example based on simple average of precision and recall, it may lead to false interpretation. Whereas the F1 score based on the formula we saw would give us a better value of predicting which model is performing better in comparison to precision and recall. All right. That brings us to the last topic in this lecture, that is AUC ROC, or area under the ROC curve. Well, it's nothing but plotting the true positive rates on y-axis and false positive rates on the x-axis. The area under this curve provides a single number that lets you compare models of different types. I know it's not very self-explanatory, so let's understand it again with an example. But before we do that, let me take you back to history and explain why is it called ROC. You can pause the video if you want and read why it is called ROC. Okay, let's try to understand how the AUC has been plotted so that you appreciate its value in comparing two different models. For this purpose, I have another model created using the bank data, and the bank wanted to predict whether a particular prospect will buy the product or not. When we look at this result, this is what we see. I have this sheet that you can download and try for your model and create your own AUC ROC curve. There we are. So what I have done is
Tú
basically
ơi, mình
changed
cái
the
này chắc
value of 3.
Ừ,
alo alo
ừ.
Tú, có nghĩa
Ok.
là để Trâm quay lại cái quiz từ nãy, chờ nó không có giữ kết quả. Làm sao mà quay được? Rồi đây. Như vậy là AOC curve với lại precision. Precision là có trong đó luôn rồi. Vì accuracy là cũng có, vậy là A square.
Regression là
Vậy là A square là cho regression.
regression
Regression là mấy cái kia.
not used. Not use the square.
A square. Mình tiếp tục nha, mình tiếp mấy câu nữa để coi có làm hết được cái này không. Vậy là A square là regression, còn AOC curve precision, accuracy là classification.
Okay. Cái này cũng chắc là
Thua.
thua.
Cái này không. Ok.
Bên trong á machine learning á có ai tốt nghiệp chưa ta? Hình như tôi nghe nói là đang có người vừa mới pass đồ án á.
Ghê vậy.
Ừ.
Châm chưa nghe.
Ủa Trâm cũng được học bổng 100% đúng không?
Ừ.
Hình như có người vừa pass tuần trước.
Ghê vậy. Đúng chưa học xong module 1 nữa chứ.
Tôi cũng đang làm đồ án đấy, data science. Đầu tốt nghiệp.
Cái này Trâm cũng không biết, Trâm nhập lại để mình xem cái video.
Nốt lại rồi xem thêm chứ.
Ừ.
Tôi có nhìn xem sơ qua cái chương trình machine learning, hình như có liên quan lasso gì đó đó. Regression, lasso regression, L1, L2. Ở bên data science thì không có đi sâu vào, cũng có nói đến nhưng không đi sâu vào.
Ủa vậy hả? Trâm tưởng là data science mới phải đi sâu vào, còn machine learning là mình có sẵn mấy cái model rồi xong mình cứ áp vào thôi á.
Nhưng mà phải hiểu bản chất đó chứ.
Vậy hả? Thì tại vì cái khóa
Hiểu bản
Intel
chất là
Edge IoT gì của Trâm á là nó có sẵn model rồi, mình không cần phải tune nhiều, mình chỉ cần áp coi kiểu như là nó lấy.
đúng. The scikit-learn đồ hầu hết mà classical machine learning scikit-learn nó hỗ trợ hết, nhưng mà mình cũng phải hiểu bên dưới nó thôi chứ.
Cái khóa kia của Sâm Hoa đó.
Hi. In the last lecture, we built our model using two-class logistic regression and ran it successfully with a very good accuracy. We saw some parameters there that our untrained model expected. In fact, every algorithm has a set of input parameters. They are also known as hyperparameters. Hyperparameters are like knobs that data scientists use to get the optimum result. All right, let's go through those parameters one by one for logistic regression. The first one is the create trainer mode option. By setting this option, you can specify how you want a model to be trained. Single parameter is when you know what is the best combination of various parameters. However, that usually does not happen. You may want to figure out the best possible combination. That is when the trainer mode of multiple parameters helps us. If you select this as an option, and as you can see, you will be able to input multiple values and even a multiple range. You should use the tune model hyperparameter when you are using multiple parameters. What it basically does is it creates various combinations of these values and runs the model multiple times with each set and provides us the best results. We have a dedicated section on tune model hyperparameters where we will cover this in greater detail. Next parameter is optimization tolerance. That's a big word, and as per Microsoft, it's a threshold value to stop the model iterations. So what does that mean? Well, as we have seen, this is the formula for logistic regression, and we say that all the values above 50% probability are positive and below that are negative. But how do we arrive at the best possible values of B0 and B1 so that we have minimum number of errors? Because if we arbitrarily give some value to B0 and B1, we may get a plot like this. So we iterate and come up with multiple options such that the number of errors are minimum. We may assign a cost function which essentially comes up with some sort of a cost, and our aim is to minimize the same. All right. It basically tries to minimize the error. In the second iteration, we may get a curve like this. We go on minimizing the errors and our curve will start converging to the best possible results. But that creates another problem of when do we stop iterating, because it will never get an absolute minimum value. There will always be few decimal or a very minimal amount that it will always have a difference from the previous model. So we provide a threshold called optimization threshold that tells the model to stop when these curves are not optimized beyond that value. I hope that explains what is optimization tolerance. Next one is the memory size for LBFGS. Let's see what it is in the same context of optimization algorithm. The cost function of an optimization algorithm may look something like this, and this point is the one with minimum cost or errors. Our model may be starting over here and trying to reach this point. It does so with the help of gradients and vectors. It has been explained in detail in a dedicated section on gradient descent. For now, let's simply know that it needs to understand its previous positions and related data in order to reach this point successfully and quickly. This parameter of LBFGS, where the L stands for limited memory, it simply provides the amount of memory to store for the past information. Right? Smaller the memory, lesser will be the history stored. So it might reach here faster but less accurate. All right. Let me explain the random number seed again. Let's say we have these 10 numbers and a random function to randomly select 3 numbers from this set. Every time we run this random function, it will produce a different set. When we train the model, we do not need different selection of data multiple times. Else, our model will produce different results every time we run it. So we simply provide this seed, which basically makes the random algorithm remember the logic it applied so that we get the same result if we rerun the experiment multiple times without changing other parameters. Finally, allow unknown categorical level option creates an additional unknown level. Let's understand that with an example. Let's say we are trying to predict the income class from a data set and we have these values in our training set. But when we try to test the model, we find that we may have some additional class and our model has not been trained on them. So what do we do? Well, this parameter creates unknown categorical levels, and any such new classes or categories that it finds are mapped to such an unknown categorical level. I hope that explains what is allow unknown categorical level parameter. Great. In case you're wondering why I have not talked about L1 and L2 regularization, well, it needs more time and hence I kept it for the last. Now, before we understand L1 and L2, it is important to know what is regularization in the context of overfitting. Let's try to understand that using regression. Let's say we have a data set with points plotted as shown here. A straight line equation can clearly demonstrate that this is underfitting. because most of the points are away from the line. It won't do any good for predicting any new data point. Similarly, in this situation, if we try to create an equation that makes the line pass through almost every data point, we will also be in a problem, as it won't be good to predict a new data point. This is called as the problem of overfitting. What we need is a trend that can predict with optimum accuracy, such as this. So what is causing this overfitting? Well, it is these coefficients whose larger values can have a significant impact on the outcome. So the B2 and other coefficients or weights are the reasons for the model to overfit. What if we can significantly reduce or maybe eliminate them by making it zero? That's what L1 and L2 regularization weights aim to achieve. They penalize the magnitude of the coefficients of features or weights, along with minimizing the error between predicted and actual observations. Alright, the L2 regularization performed by the ridge regression, it shrinks all the coefficients by the same proportions, but it does not eliminate any of those. Whereas the L1 regularization or the lasso regression, it will shrink some of the coefficients to zero. Okay, so what I mean by that is, in this example, if we use higher values for L1, it might even make B2 as 0, and hence it prevents the overfitting. So the X or the feature associated with this coefficient might not even be selected. So what we are saying is it is also doing some sort of variable selection as well, and we will have more relevant features or variables in our equation. Great. As we have seen, both L1 and L2 regularization prevents overfitting by shrinking, or we can say imposing a penalty on the coefficients. With L2, you tend to end up with many small weights or coefficients, while with L1, you tend to end up with larger weights but more zeros. So, if you believe that it has got too many features and some features are actually creating the problem of overfitting, try increasing the value of L1, right? For further details, and if you are interested in knowing the theory behind it, I suggest you go through a very good article that explains what is L1 and L2 regularization on this website called analyticsvidya.com.
Cái này
I have shared the link here, or
cái này Tú mới nói là đúng không Tú? Lasso regression.
Đúng rồi, lasso là L1, L2, lasso with này. Thì cái này là có trong chương trình Trâm đang học á.
À vậy hả? Trâm cũng chưa coi rồi.
Tức là nó gần cái chỗ một mà neural network luôn.
Chắc là mình phải đi qua tiếp cái chương trình Trâm đang học sau để Trâm nghĩ chắc là nó gần cái thi á, tại vì cái này là cũng là machine learning fundamental.
Chương trình Phoenix đó.
À chương trình Phoenix hả?
Đúng rồi.
Chương trình Phoenix không biết bao giờ.
Mà tôi nghĩ cái đó quan trọng, tại vì Xui là một người đã từng làm data science rồi, và thấy cũng nhắc nhiều lần tới cái regularization mà có L1, L2 này, tức là liên quan đến risk với lại lasso regression này.
Đức muốn xem cái link không, để cho mở nhanh cái link xong mình coi cái link coi
much higher in Azure. Thank you so much for studio, as I want you me using logistic. I hope that clears the concepts behind logistic regression. That clears the in Azure ML. I want you to thank you. The first model using rather than some false fraud, the threshold value
Tú có
can be
nhớ cái
decided
link nó ở
based
đâu?
on the business application and what is okay. And I ask you to solve it as why is our data much and others what is the cost of particular transaction to get some form that clears the concepts behind. Let's build our this along with me next lecture. So adding logistic behind
L1,
logistic
L2 rồi.
regression in
Ở trong nhớ
next.
ông còn đưa
Okay,
cái link nữa.
and P because
Để
the overall
bữa sau Trâm lấy cái
probability.
link rồi xong không tí nữa Trâm tua lại Trâm lấy cái link Trâm gửi Tú với xuôi luôn. À, không biết sao
Đúng
Trâm
rồi, trong tour tới gần cuối ấy, cái đoạn gần cuối ấy,
à
cái chỗ mà
Trâm thấy cái
có
chữ thank you.
đó.
À
Từ coi lên trước một xíu, lên trước một xíu. Đó. Quay.
Log into the Azure ML Studio as I want you to do this along with me. Thank you so much for joining me in this one,
Ok.
and I'll see you in the next lecture. Until then, enjoy your time.
Ủa, trời ơi, công ty của Trâm là mấy giờ làm?
9 giờ làm lận Tú.
Thủ ngoại học
Thì
làm
mấy
machine
bữa
learning.
nay có dịch lại rồi đi sớm để khỏi đi thang máy. Trâm sợ đi thang máy lắm.
Đúng, đi thang bộ
Ừ,
đi, nên đi thang bộ.
đi thang bộ cho nó an toàn.
Ok, thôi have a nice day.
Ừ, bye bye Tú. Bye.
Bye bye.
Bye bye.
See you tomorrow.
Ừ, bye bye.